In this video, we are going to use the insertion sort algorithm to sort this list of numbers 92, 23, 2, 10, and 48 in ascending order. The insertion sort algorithm works by first taking the value in the second position of the list and comparing it to the value in the first position of the list. If the value in the second position is less than the value in the first position, the numbers are swapped. If not, both values remain in place. Next, the value in the third position is compared to the value in the second position of the list. If the value in the third position of the list is less than the value in the second position of the list, the numbers are swapped. If not, both values remain in place. Now here, if the value in the third position is less than the value in the second position, it must also be compared to the value in the first position in order to find its appropriate position in the sorted list. This process continues until the list is completely sorted. Let's look at an animation of the insertion sort algorithm being ran on this list of numbers to get a better understanding of how it works. Once again, the list contains 5 values: 92, 23, 2, 10, and 48. First, the value stored in the second position of the list, 23, is compared to the value stored in the first position of the list, 92. Since 23 is less than 92, the values are swapped so that the smaller value, 23, takes the lower position. Since there are no other previous values in the list for 23 to be compared to, we move on to the next value to be compared, which is the value stored in the third position, 2. 2 is first compared to the value in the second position, 92. In this case, 2 is less than 92. And since there is still a previous value in the list to compare 2 to, it is compared to the value in the first position, 23. 2 is also less than 23, and since there are no other previous values to compare 2 to, all values 2 is declared to be less than are shifted to the right so that 2 can be put in its appropriate position, the first position. Next, we move on to the next value to be compared, which is the value stored in the fourth position, 10. 10 is first compared to the value in the third position, 92. In this case, 10 is less than 92, and since there is still a previous value in the list to compare 10 to, we will compare 10 to it, which in this case is 23. 10 is also less than 23, and since there is still a previous value in the list to compare 10 to, we will compare 10 to it, which in this case is 2. 10 is not less than 2, so at this point we stop comparing 10 to any other previous values. We shift all values 10 was declared to be less than to the right and place 10 in its appropriate position in the list. Next, we move on to the next value to be compared, which is the value stored in the fifth position, 48. 48 is first compared to the value in the fourth position, 92. In this case, 48 is less than 92, and since there is still a previous value in the list to compare 48 to, we will compare 48 to it, which in this case is 23. 48 is not less than 23, so at this point we stop comparing 48 to any other previous values. We shift all values 48 was declared to be less than to the right and place 48 in its appropriate position in the list. At this point, the list is completely sorted. The insertion sort algorithm has a time complexity of big O of n squared in the worst case and big O of n in the best case.